Good afternoon, grade 12 learners. My name is Mohapi, Mathematics Subject Advisor here in Mutao District. So today I'm here to discuss with you the three-dimensional problems in trigonometry. You know, trig basically is divided into three sections: the normal trig, the trig functions, and the 2D and 3D problems. Two-dimensional and three-dimensionals. Commonly, to shorten them, we just call them 2D and 3D problems. But for today, I will focus mainly on the 3D problems. Remember, this is a topic which requires understanding. That's why we always advise teachers, when you present this topic, you need to bring models into the classroom, so that learners can then start understanding what we mean by vertical, horizontal, plane, and so forth. They should be able to see all the three surfaces: the vertical, the horizontal, and the vertical plane. It's a topic that requires teachers to bring in models in class so that learners can then make sense of what a three-dimensional problem is, so that when we solve these problems, then it becomes easy. Nonetheless, this topic, I know, this is the topic that was done the first week in term 2. So we have already been presented with models and explanations on what three-dimensional problems are. So today my focus will be mainly on the application of these three-dimensional problems. Take note. For us to solve three-dimensional problems, 3D problems, it requires us to know the following. Number one, learners must know the definition of trig ratios. Trig ratios. What do I mean by that? Learners must be able to define sine, the cosine, and the tangent in terms of a right-angled triangle, in terms of the sides of a right-angled triangle. We know sine is defined as opposite side over the hypotenuse, cosine is defined as adjacent over hypotenuse, and tangent is defined as opposite over adjacent. Those are the definitions that are really very much important, that will play a very key role in enabling us to solve problems related to 3D problems. Once you know the definitions, you must also remember this topic. You cannot do this topic in isolation from Euclidean geometry. So the basic knowledge of Euclidean geometry is also needed. Basics of Euclidean geometry. The basics of Euclidean geometry, like if you talk of a parallelogram, automatically it means as a grade 12 learner who's doing trigonometry, you must know the properties of a parallelogram. If you are given a problem and it is stated that that quadrilateral is a rhomba, then you must know the properties of a rhomba. Isosceles triangles. Once you have a cyclic quad, what is a cyclic quad? You must know the properties of a cyclic quad. That's why I'm saying this topic, you cannot treat it it's not a topic in isolation. It's not independent. You must have good background from Euclidean geometry. And you will see, as you do some of the problems, you will see we have to bring in the issue of trig ratios. You have to bring in the basic, the Euclidean geometry. Number 3, we have the rules that we need to use. We have, number 1, there are 3 rules. The rules. Number 1, there are 3 rules. Let me say the first rule will be the sine rule. Secondly, the cosine rule. Thirdly, the area of a triangle rule. The area of a triangle rule. Remember, according to sine rule, in any triangle ABC, A over sine A is equals to B over sine B is equals to C over sine C. Cosine rule, in any triangle ABC, A squared is equal to B squared plus C squared minus 2BC, the cos of A. The area rule, the area of any triangle ABC is equal to half AB. Once you talk of AB, then it will be sine C, and so on and so on. These are the basics that are really important. Once you are well grounded with these three concepts that I've written here, then you won't have much of a problem in solving three-dimensional problems, 3D problems. Let me repeat myself again. I'll be slow this time. Grade 12 learners, know the definition of the trig ratios. How do we define a tangent in terms of the sides of a right angle triangle? How do we define sine in terms of the sides of a right angle triangle? And how do we define the cosine in terms of the sides of a right angle triangle? Know the basics properties of quadrilaterals, know the properties of triangles, have the basics of Euclidean geometry when we come to solve this problem. Number 3, know your rules, the sine rule, the cosine rule, and the area rule. Those are mainly, not only, but these are mainly the key concepts that will be very much helpful in proving this, solving problems related to 3D problems. Talking of these three, trigonometry, as of this year, since 2021, this is the topic, trigonometry as a topic. It carries 50 marks. It carries 50 marks in paper 2. It's part of maths paper 2. It carries 50 marks in paper 2. Out means at the end of the year, as grade 12 learners sit for the final exam, paper 2 will be 150. 50 marks comes from Euclidean geometry. And in this Euclidean geometry, there is what you call the bookwork. There is what you call bookwork. What do we expect from bookwork? Be able as a grade 12 learner to prove the area rule. Be able as a grade 12 learner to prove the cosine rule. As a grade 12 learner, you are also expected to be able to prove the area rule. I think I've made myself vividly clear. I'm talking in terms of trigonometry. I know there'll also be the reduction formulas and the compound angle identities and so forth, which forms part of the bookwork. Let alone the definition of the theorems in Euclidean geometry. But for today, the focus is on trigonometry. And in particular, the three-dimensional problems in Euclidean geometry. So this area rule, cosine rule, sine rule, they constitute part of the bookwork. They can be regarded as part of bookwork. So grade 12 learners, be ready. This is, in short, what is expected from a grade 12 learner. From now onwards, for the remaining 40 minutes or so, the focus will then be mainly on the application, because it is in application where more marks can be obtained. Nonetheless, it is important to know bookwork. By bookwork, I'm referring to sine rule, cosine rule, and the area. Those rules you must be able to prove. Let me show you an example of the question where the examiner asked learners to prove one of the three rules. Good. Check the very first 7.1, that first question. Let me make it bigger. Thank you. 7.1, prove that in any acute angled triangle, ABC, sine A over A is equal to sine B over B. 5 marks. 5 marks. Just an example. Or sometimes the question can be, if it's a cosine rule, prove that in any acute angled triangle ABC, C squared is equal to A squared plus B squared minus 2AB, the cos of C. C squared is equal to A squared plus B squared minus 2AB, the cosine of C. if you were required to prove the cos rule or the sine rule, it's a book work. That's why I encourage grade 12 learners to go to any CAPS compliant textbook. Just take any CAPS compliant textbook. You'll come across those proofs. Because of time, I won't be able to dwell into the proofs, but that is what is expected from a grade 12 learner. You must know the proofs. Even the area rule, to prove that in any acute angle triangle ABC, the area of triangle ABC is equal to half AB sine C. If you talk of AB, then it will be the sine of angle C. If you talk of BC, then it will be the sine of A. If you talk of AC, then it will be the sine of B. It's an example of the proof type of questions, part of the bookwork. Thank you. Let's try and do another problem related to 3D problems. Check this one. There is the question. There is the question. The framework for a construction consists of a cyclic quadrilateral, PQRS. Remember what I said earlier. Know the basics of Euclidean geometry. Now here we are given cyclic quadrilateral. In short, cyclic quad. What are the properties of a cyclic quad? If you do not know the property of a cyclic quad, you won't be able to answer this question. And cyclic quads are dealt with in Euclidean geometry, you know, the circle geometry in grade 11. So hence I said it's important to have that basic knowledge of properties of quadrilaterals. Cyclic quad is a four-sided figure. So this cyclic quad PQRS in the horizontal plane and a vertical post TP. Here is the vertical post TP. Cyclic quad is PQRS. From Q, the angle of elevation of angle T is y decrease. Here is y. PQ is equals to PS is equals to K. So here is PQ, it's marked K. See? What is P? It's PS. PS, here is PS. It is marked K. It means as a learner, you go to PQ, you also mark it K. Because it is given from this statement, PQ is equals to PS, and they are both equals to K. TP is 3 units. Here is TP, 3 units. And angle SRQ is 2x. It's important for a grade 12 learner to be able to indicate the given information on the diagram, so that as you work out the solution, you work with the diagram. You focus on the diagram. You know your diagram is rich. You have put all the necessary information on the diagram. Like, for instance, PS is K, PQ is also K, because the two sides are equal. Here they only gave you PS equals to K, so as a grade 12 learner, you must be able to indicate K here. Let's look at the first question. Show, given reasons, that angle PSQ is X. PSQ is X. Let's try this one. Angle PSQ is equals to X. Let's try and work out the solution. Check this one here. Thank you. How do we solve this one? Show, given reasons, that angle PSQ is equals to X. It's angle PSQ is equals to X. Let me try and simplify. I can say I've got angle S1 here, S2 here. That is why it's Q1, it's Q2. I'm trying to simplify so that we can easily work out the solution. Angle R is equal to 2x. What will be the magnitude of angle? Let me say this one is P1. P2 is 90 degrees. Let me say it's P1. How can we prove 7.2.1? 7.2.1. If you look at 7.2.1, let's first calculate the size of angle P. Then we'll say angle P1 plus 2x. This is 2x, this angle here. It's 2x. They must give us 180 degrees. Those are the opposite angles of a cyclic quad. Those are the opposite angles of a cyclic quad. Therefore, you make P1 the subject of the formula. Therefore, angle P1 is equal to 180 degrees minus 2x. Angle P1 is equal to 180 degrees minus 2x. Remember, every time, from time to time, you must have the question. Prove that PSQ, basically it's S1, PSQ, I have marked it S1, this angle here. You need to prove that S1 is equal to X. Now that we've got this one, look in triangle PQS. Let me write down. In triangle PQS, inside that triangle PQS, what do we have in that triangle? Angle P1 plus S1 plus Q1, they should give us 180 degrees. Those are the sum of angles in a triangle. Now let's substitute. P1, remember P1 we have calculated to be, here it is. P1 is 180 minus 2x. So instead of P1, we substitute P1 by 180 degrees minus 2x. 180 degrees minus 2x. Plus, we want to calculate S1. So S1 is here. Leave it as it is. Q1. If you check, Q1 and S1, those are the angles opposite equal sides. So angles opposite equal sides are equal. So if they are equal, we substitute Q1 by S1. This must give us 180 degrees. Why do we substitute? Take note, it's because angle S1 is equal to angle Q1. Those are the angles opposite equal sides. Angles opposite equal sides. So let's work it out. 180 degrees minus 2x plus S1, they give us 180. Let's add. S1 plus S1 will give you twice S1. S1 and S1, we added the 2, they give me twice S1. I take this 180, I transpose it to the right. Now it becomes 180 minus 180, it's 0. This negative 2x, I transpose it to the right, it becomes 2x. Now, simple arithmetic, divide by 2 both sides. If you divide by 2, you'll find that S1 is equals to X. Perfectly done. Perfectly done. S1 is equals to X. The first question has been answered. Show, given reasons, that PSQ is equals to X. You see why they say given reasons? The only the topic that requires reasons in mathematics is Euclidean geometry. Now we are discussing trigonometry. You see, the reasons are needed because in this topic, in it, Euclidean geometry is built in. So you must, from time to time, apply Euclidean geometry theorems. That is the solution to the first one. So here it is now. S1 is equal to X. We have calculated that this angle is equal to X. Even this one, because they are opposite equal angles, it is also equal to X. Thank you. Let's read the second question. Prove that SQ is equal to 2k cos X. SQ. Where is SQ? SQ is equal to 2k cos X. Look at it, think about it, and let's try to come up with the best way out. Look in triangle PSQ. In that triangle PSQ, we want to calculate SQ. We want to calculate SQ. In triangle PSQ, this SQ that we want to calculate. We have this one as K. Remember, even this one is also K. So, in this triangle, you have these two sides and the included angle. So it clearly shows for us to determine SQ, we must use the cosine rule. We must apply the cosine rule. Check. Let's apply the cosine rule in this triangle. SQ squared, the question here is the question. Prove that SQ is equal to 2k cos x. Now we say SQ squared is equals to, remember this side is equals to PS squared, and a PS is K. It's K squared plus PQ squared. PQ squared is K. K squared minus 2 PS, it's K. PQ is K, the cos of the included angle. The included angle here will be angle P1. And angle P1 is equal to 180 degrees minus 2x. The cos of 180 degrees minus 2x. Now, let's try and simplify and solve it out. Let's check what we have. SQ squared, you add this to k squared plus k squared, they'll give you 2k squared. 2k squared. You multiply here, you've got minus 2 multiplied by k is going to be 2k squared. Now you have the cos of 180 degrees minus. Remember, according to reduction formulae, 180 minus second quadrant. And in the second quadrant, the cos is negative. So that negative will change. You've got plus. Hence, we've got the cos of 2x. Cos of 2x. Look at it. Remember the target, the question. We need to prove that SQ is equal to 2k cos x. We have 2k squared plus 2k squared cos 2x. Fine. Let's take out 2k squared as a common factor. Or let's expand this one. Cos 2x. Cos 2x, such that, remember, there are three possibilities. For cos 2x can be cos squared plus sine squared. But look at the question. The question has got cos. The question has got cos. So we must apply the correct double angle identity. There are three. Cos squared plus sine squared. Or you can say cos 2x is equal to 2 cos squared x minus 1, or it can be 1 minus 2 sine squared x. So let's check. The most relevant one will be the cos. 2k squared plus 2k squared cos 2x, then will be 2 cos squared x minus 1. 2 cos squared x minus 1 from double angle identity. Cos 2x will be 2 cos squared x minus 1. Let's write it down. 2 cos squared x minus 1. Let's expand and let's multiply 3 out by 2k squared. I've got SQ squared is 2k squared plus, let's multiply here, 2k squared to multiply here is going to be 4k squared cos squared x minus 2k squared. What I did was just to multiply throughout by 2k squared. So that 2k squared minus 2k squared is 0. What is left? What is left is SQ squared, which is equal to 4k squared cos squared x. Now, the question, let me take you back to the question. Prove that SQ is equal to 2k cos x. It means now you need to eliminate the square. And how do we eliminate a square? We eliminate a square by introducing square root. So what is the square root of SQ squared? The square root here will be SQ. Remember, square root plus or minus, but because we're working off the length here, SQ represents the length, we focus on the positive values. The square root of 4 will then be 2. The square root of k squared will be k. Cos squared x will then be cos x. And this is exactly what we are required to prove. This is exactly what we are required to prove. Thank you very much. Perfectly done. We have proven that SQ is equal to 2k cos x. The last one. The last one. Hence, the word hence. Let me talk about the word hence. Grade 12 learners, you listen attentively. If we talk of the word hence from mathematics point of view, from mathematics perspective, it means you use the answer you obtained in 7.2.2 to solve 7.2.3. I think I've tried to explain it. Hence, in this case means the answer that you obtained in 7.2.2, you are going to use it to solve or to answer 7.2.3. Let's go. 7.2.3. Let me go. Hence, prove that SQ, remember, let me be slow. This is SQ. We have SQ again here. Prove that SQ is equal to 6 cos x tan y. Let's go back to the diagram. Let's do 7.2.3. We have the tangent of y here. It guides you. The proof type of questions, I like them because they give you guidance. You have the tangent of y here. Therefore, you will say the tangent of y is equal to, look at the diagram. Grade 12 learner, how do we define tangent? Tangent is defined as opposite over adjacent. Opposite over adjacent. So you must look at, here is angle y, here is angle y, so the opposite side will be 3, the adjacent will be k. So tangent is opposite over adjacent. It will be 3 over k, opposite over adjacent. That is the tangent of y. Then tan y is equal to 3 over k. Let's work it out. The tangent of y is 3 over k. Now we go back to this answer we obtained here. Remember in 7.2.2, so we've got SQ, which is equal to 2k cos x. 2k cos x. But remember the value of k. Now, it means from this one, we can make k the subroot formula. From this one, therefore, let's make k the subroot formula. If you make the k the subroot formula, k will then be equal to 3 divided by tan y. That is k. K is equal to 3 divided by tan y. Then we come to this one. SQ is equal to 2k cos x. SQ is equal to 2. Instead of k, we write 3 over the tangent of y. This is k, ne? This is k multiplied by cos x. We know it's over 1, it's over 1. Here is our SQ. I'm sorry. 2, here is 2 is 2 over 1. K, we substitute k by 3 over tan y. But instead of k, we write 3 over tan y. Here is cos x there. And if you simplify it further, SQ will then be equals to 2 multiplied by 3 multiplied by the cos. It's going to give you 6, the cosine of x, all over 1 multiplied by the tangent of y multiplied by 1, which will then give you the tangent of y. And this is exactly what was expected from us. This is exactly what we are required to prove. When you solve problems, you look at the word hence. The word hence means use the answer obtained previously to answer this one. That is why, in this case, for us to arrive at this answer, For us to arrive at this answer, we had to use 7.2.2, which is SQ is equals to 2K cos X. Why the word hence? Grade 12 learners, I hope you understood. The word hence means use the solution in 7.2.2 to answer 7.2.3. In this case, use the answer obtained previously to answer this one. Thank you. And this brings us to the end of these questions. We have already answered 2, 4, and 2, it's 8 marks, plus the previous one, which was the bookwork, where you have to prove the sine rule. Here it is. Thank you. This was the question earlier. We managed that one. I said it's a bookwork. You go back to those any CAPS compliant textbook for the answer to that question, and we did this one. And we did this one as well. All I'm saying is, if you remember, when I started at the beginning of my session, I emphasized this. At the beginning of the sessions, this is just a brief summary of the notes I gave you. For you to solve 3D problems, definition of trig ratios, and I think you will agree with me, in this problem that we just did, we needed the definition of trig ratios, the tangent of y, which is opposite over adjacent, for us to get 3 over k, if you still remember. Basic Euclidean geometry, we talked of the opposite angles of a circle quite supplementary. That is the knowledge that we talked of sum of angles in a triangle is equals to 180 degrees. We talked of opposite angles. Okay, so I'm sorry, angles opposite equal sides are equal. Just in that previous, the only one problem that we only did one, but check the number of theorems that are embedded in that problem. Hence I said, have your basics of Euclidean geometry right, then you'll be able to solve this. And I also emphasized number 3, the bookwork. Be able to prove the sine rule, the cos rule, and the area rule. Thank you. Thank you. Time is still on our side. We can do one more problem. Check. I prepared lots and lots of problems. The next one that I wanted us to discuss was this one. In the diagram below, RS is the height of a vertical tower. Let's look at the diagram. Relax, grade 12, and remember you apply your mind. In the diagram below, RS is the height of a vertical tower. Here is RS. It is a height of a vertical tower. T and Q are 2 points in the same horizontal plane as the foot S of the tower. Here it is T and Q. They are in the same horizontal plane as the foot of the tower, because this is a vertical tower. From point T, from here, the angle of elevation to the top of the tower is 60 degrees. Here is that angle 60 degrees marked. RTQ is theta. RTQ, the whole of this angle is theta. Here is theta. And it's theta. TQ is K meters. So that's TQ, here is TQ. TQ is K meters. You have the diagram. Now, there comes the question. Let's go. Express TR in terms of theta and K. Express TR in terms of theta and K for 3 marks. It's the first question. Use the information given. Here is theta, here is K. What does that mean? For me to express TR this side. Already I can sense, I have to, in this triangle, I have this angle as theta, I have this angle as 60 degrees. I can work out the size of that angle, TRQ. We can work out the magnitude of angle TRQ. Let's work it out, angle TRQ. Let's check the magnitude of angle TRQ, okay? Thank you. This is the diagram drawn. Thank you. Here is the question. Express TR in terms of theta and K. So we have this angle as 60. This one is theta as a whole. Let's work out this angle. As you can see, it's R1, R2. So express TR in terms of theta. Let me work out the size of R1. Remember, 60 degrees, this 60 degrees here, plus theta, this is theta, plus R1. They will give us 180 degrees. Those are the sum of angles in a triangle. Basic Euclidean geometry. Triangles. Sum of angles in a triangle add up to 180. Therefore, angle R1 will then be equals to 120 degrees because it's 180. You transpose this 60. 60 you transpose is 180 minus 60. It gives you 120. This theta you transpose, it becomes minus theta. That is R1. Now that I've got R1, I can apply the sine rule. The sine rule. I've got TR here. I've got TR over the sine of Q, which is 60 degrees. TR over sine Q. I'm focusing on triangle TQR. Grade 12 learner, focus on triangle TQR. And now we apply the sine rule. So TR over sine 60 will be equals to K over the sine of, what is angle R1? The sine of 180 degrees minus theta. Now you make TR the subjective formula. You multiply by sine 60. Remember, TR, let me see, TR will be equals to K multiplied by the sine of 60 degrees all over the sine of 180 degrees minus theta. What is the sine of 60 degrees? It's a special angle. Sine of 60 degrees is a special angle, square root of 3 over 2. Therefore, TR is equals to K, the sine of 60 square root of 3 over 2, to the sine of 180 degrees minus theta. That will be TR when we express TR in terms of K. TR will be equals to K multiplied by square root of 3. Where did we get the square root of 3? Remember, special angles. The sine of 60 degrees is equals to the square root of 3 over 2. Sine of 60 is equals to square root of 3 over 2. So here is square root of 3, here is 2. Here is square root of 3, here is 2. Square root of 3 numerator, 2 denominator. Now we have expressed TR in terms of K and in terms of theta. Here is theta, here is K. We have expressed TR in terms of theta and K. Clear? Done. Answered. Let me read the question from here, where it's a bit clean. Thank you. Remember, now we have TR, which is equals to K multiplied the square root of 3 all over 2 multiplied by the sine of 180 degrees minus theta. This is the result that we obtained for 10.1. Next question. For 7 marks. Show that RS, where is RS? Look at RS. RS is equals to this. 3K over 2, the square root of 3, the cos of theta plus sin theta. Every time, check the information you obtained earlier. Here, we had TR. Now we know the length of TR. We know the length of TR. TR here from TR. TR. We have calculated TR to be K the square root of 3 over 2 the sine of 180 minus that. Now let's show that RS is equal to that. Let's go. Look at RS. We need RS, and you need, let me make it clear. You have 60 degrees here. You have this RS. Here is RS. You have TR. You know TR. Use the size that you know. Why would you want to use TS? Because TS we do not know. Here is TS, the horizontal. TS we do not know. But we know TR from 10.1. From 10.1 we have TR. Now in 10.2 we want RS. And you have this angle here, 60 degrees. So it tells you, if you can look for the sine of 60, it will be opposite over hypotenuse. Sorry for that. Sine of 60 will be RS, which is opposite, over RT, which is hypotenuse. We apply the definitions. Then it means sine 60 degrees, the sine of 60 degrees will be equals to RS over TR, Check my work out. There I am. This is the answer I obtained in 10.1. Now I am working out 10.2. I hope you'll still be able to follow 10.2. And then in 10.2, this is what I want. I want to show that RS is equal to this. Now 10.2 started here. From the diagram, I said sine 60 is equal to RS over TR. Now I need to make TR the subject of, I need to make RS the subject of the formula. What is the sine of 60? Sine of 60 is square root of 3 over 2, which is equal to RS over TR. Make RS the subject of the formula. Therefore, RS will be equal to TR multiplied by the square root of 3 all over 2. That will be RS. Square root of 3 multiplied by TR all over 2. That will be RS. Remember what you want. Check from time to time. Check what is it that you are required to prove. We need to show that RS is 3K. RS is 3K. Now, let's use the information obtained earlier. This one. TR. Our TR is 2, is K multiplied by square root of 3. All over 2, the sine of 180 minus theta. TR. If I worked it out correctly, let's go back to the diagram a minute. Sorry for that. We said R1. R1 is, in this case, our R1, it was 120 degrees. Let me use this diagram again just to refresh you. 60 degrees plus Q, 60 degrees, this 60 plus theta plus R1 is 180, therefore R1 is 120 degrees minus theta. So TR over 60 is equal to K over the sine of 120. I've made a mistake here. Should be 120 minus theta. Should be K over R1. And K over R1 is 120 minus theta. Pardon me for the mistake. Where you see 180 here, it should have been 120 degrees minus theta. Pardon me for that. Now let me come back here. It means here we have 120. It should be 120 degrees minus theta. TR. Now we are going to substitute this TR here. RS is equals to, instead of TR, we have square root of 3 over 2. Let me write square root of 3 over 2. Here it is, square root of 3 over 2. Now I want to write TR. Instead of TR, I write, here is TR. I write this one, K the square root of 3, K the square root of 3 over 2 multiplied by the sine of 120 degrees minus theta. Just a direct substitution. Now let's simplify. Square root of 3 multiplied by square root of 3, it will give me 3. Square root of 3 multiplied root 3 multiplied by root 3, it will be 3. Now I have 3k as my numerator. I've got 3k as my numerator. All over 2 multiplied by 2 is going to give me 4 into multiplied by the sine of 120 degrees, the sine of 120 degrees minus theta. Now let's apply the compound angle identity for psi. RS is equals to 3k over, this is 4, multiply 4 into, if we apply the compound angle identity for sine, it's going to be the sine of 120 degrees, the cos of theta, minus, it was the sine of 20, now it's going to be the cos of 120, sine theta. Thank you. Now we have applied the compound angle identity for sine. We have applied the compound angle identity for sine. Then if we simplify it further, let's check RS is equals to, our numerator is still 3k all over 4 the sine of 120. Remember, it's 180 minus 60, sine of 60, and this is the second quadrant. So sine thereof will be square root of 3 over 2 multiplied by the cos of theta minus, we've got the cos of 120 here, the cos of 120. Remember, 120 is in the second quadrant, and the cos of 180 minus 60, then it will be minus cos 60. And the cos of 60 is half. So because of minus, this will then turn to positive, half sine theta. Thank you. We are almost there. We are almost there. All we have to do is to simplify the denominator. Multiply throughout by 4. I've got RS is 3k all over. We multiply by 4 here. 4 multiplied by 2, they cancel 2 the square root of 3. 2 the square root of 3, the cos of theta. Your multiply here is going to be plus 2 sine theta. All you have to do is to take out 2 as a common factor in the denominator. If you take out 2 as a common factor in the denominator, hopefully you'll get the answer that, if you take out 2 here, you'll be left with square root of 3 cos theta plus sine theta. And that will be exactly what we are required to prove. Check. Check what we are required to prove. Show that RS is equal to 3k. If you take out 2 as a common factor from the previous one, it's got 2 into the square root of 3 cos theta plus sine theta. That will be the final step. And normally is the step that is already given in the question paper. We need to prove it. So here it is here. Hence I said you need denominator, take out 2 as a common factor, then you will have exactly the statement that you were required to prove. In mathematics, we say practice and practice and practice is the best teacher. You do lots and lots of activities. The more activities you do, the better you become and the better understanding. Just remember the key concept that I emphasized at the beginning of the lesson. Definition of trig ratios, the basics of Euclidean geometry, sine, cos, and area rule. Once you can grasp that, I believe you'll do well in this topic. Let me take you through some of the examples. Because of time, I won't be able to do them with you. Here are some of the problems that we can do. But this one is the simple 2D problems. This one is simple 2D problems. If you have time, you play in this video, you can then copy it and solve it. I prepared a lot. Here is one other. Thank you. Can read the information given, indicate the information on the diagram, and in this one, I think all the information was given in the diagram. Once you can indicate the given information on the diagram, go through the questions, and try to answer those questions. Like I said, practice and practice is the best way to understand mathematics. The more you practice, the better you become, the more confident you become in the topic. Due to time, we've come to the end of the session for today. I hope grade 12 learners, you will do lots and lots of activities relating to 3D problems. These topics seem to be a monster amongst grade 12 learners. However, I still believe if we can dedicate time in solving these problems, they are not really that difficult, because it's basically about the basics of Euclidean geometry, the definition of trig ratios, and the application of the sine, cos, and the area rule. So once you have all those concepts correct, all these problems will become easy. Do not be, terrorized by the diagram. Most of the learners, by merely looking at the diagram, they become fearful. Hey, you are dealing with triangles and quadrilaterals. That's it. Triangles and quadrilaterals. That's it. Stick to the basics of triangles and quadrilaterals. Then you'll solve any problem. By merely looking at this one, I can see 60, this side is x plus 2. Work with what you know, then you'll be able to know the unknown. Like here, CE, 7.1.2, CE, you see? I've got 60, I've got the adjacent, I do not know the hypotenuse. Which functions works with adjacent over hypotenuse? It's a cos. Once you say cos 60 is equals to x plus 2 over CE, you have already answered the question. Focus on triangles and quadrilaterals. Then you'll see these problems are not really that difficult. And practice makes perfect. Grade 12 learners, thank you for watching. Enjoy the sessions. Good luck with your studies.